Welcome back to Namaste Node.js. In this video, we are going to dive deep into libuv. We are going to see how things work internally inside libuv. We are going to talk about event loop, we are going to talk about thread pool and a lot of amazing concepts. Let me tell you, my dear friends, this is the most important and the most complex video of this whole series. It will talk and dive deep into a lot of amazing core concepts inside Node.js. We are going to unfold a lot of mysteries inside this video. And let me also tell you that this is very important videos for your interviews because a lot of concepts which I will cover in this video will be asked in your interviews. So pay utmost attention, pay a lot of attention when I am teaching you anything. Please bring your notebook and a pen with you and keep taking down notes with me. That's very, very important. It's going to be complex, I'm telling you right at the starting of this video. And it's my responsibility as a teacher to make this complex thing as easy as possible for you to understand. And trust me, you will love Node.js even more. Are you in love with Node.js already or not? If you are not, you will fall in love with Node.js now after this video. Okay, so let's just begin and explore the world of libuv, my dear friends. Okay, so let's just start. So you already know that we have Node.js and there are two major things inside Node.js. I've been keep telling you, I'm just telling you this statement since a lot of time, right? In all the previous episodes, I have reiterated this thing that Node.js has two core major portions of it. The first one is the V8 JavaScript engine, right? It runs on a main thread, you already know that, and libuv. Right now in this video, we are going to talk and dive deep into this libuv and what it does, how it does, and a lot of other complex things. Okay, now let me just tell you first of all what is there inside libuv. Okay, so that will be interesting. So let me move on to the next slide. So in libuv, right, inside the Node.js, in libuv, there are three major components. The first one is the event loop. The second is the callback queues, and the third is the thread pool. Okay, we already know, right, a lot about V8 engine. We already know a lot about node architecture, but we have not seen about libuv, right? So this is what we are going to explore and dive deep into each of it. What happens inside the event loop, what happens inside the callback queue, what happens inside the thread pool, everything we will see in this video. Okay, so get ready for exploring this journey. Okay, now we already know that whatever code you write, whatever Node.js JS files you write, that code is run inside V8 engine. But some of the things, some of the asynchronous tasks are offloaded to libuv, right? This is what we have studied in previous episodes. So a lot of code is run synchronously, right? JavaScript is a synchronous single-threaded language, right? You already know that. JavaScript does not wait for anything. You already know that. Time, tide, and JavaScript does not wait for anyone, right? Remember this? Okay, so what happens is whenever the code is executed and there is some asynchronous task which might take some time. Suppose you are making an API call. So you cannot block the main thread while you are making an API call, right? You can do the rest of the stuff. So what happens is such asynchronous tasks are offloaded to libuv. We have already seen that how it happens in the previous episodes. We are going to see how things work internally in this episode. Okay, so when these tasks are offloaded, so a lot of things happen inside this libuv. This is what we are going to see in this episode. Now, let me also tell you about libuv that asynchronous IO and non-blocking IO in Node.js can only be done because of libuv. Libuv is a superhero, my dear friends. I have told you a lot of times. Libuv is a genie. Libuv is a superhero. Libuv is the one which makes asynchronous and non-blocking IO possible in Node.js. Node.js is popular because of asynchronous and non-blocking IO. And the main reason for this asynchronous and non-blocking IO is libuv. So what I am telling you is libuv is a very, 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 very important library when it comes to Node.js. Okay, so understanding it is also very important and you should know how things work inside libuv. Okay, so let's just go ahead and let me just dive deep into it. Slowly, I will make you understand a lot of core concepts inside Node.js and how things work internally. Okay, so let's just start. Now, I will take an example which we have already seen earlier. In few of the previous episodes, I have taken the same example of how this code runs inside this whole Node.js architecture. But now let me explain this once again, right? So that our knowledge of the previous episodes is revised, and I will add extra information inside it about libuv. Okay, so let's take an example. In this is a code example which has synchronous as well as asynchronous code. This is synchronous code, this is synchronous code, this is all asynchronous code, right? Basically making an API call. We have seen this example already, right? Just read it once again. If you don't understand this, just pause the video and read this code once for a while, okay? And then continue with the video. So this is an API call, right? This is an API call. This is set timeout. You already know that, okay? This is a callback function which will be called after 5,000 milliseconds. This is a file read operation. We are reading this gossip.txt over here. So these are all asynchronous tasks. Now, how this code is run is, we already know that, okay, JavaScript engine, this whole code will run inside the JavaScript engine over here in the call stack. We already know that, right? And how this code will run? Because JavaScript is a synchronous single-threaded language, this code will run line by line inside the global execution context. We already know all of this. Now, when this code will run, how this will run, let me just explain you once again. First of all, this line will run, then this line will run, then this line will run, right? Because this is asynchronous thing, this https.get, this is an API call. So JavaScript V8 engine will say, oh my God, this is an asynchronous task. Let's offload it to libuv. So this task, this API call will be offloaded to libuv. Right? Similarly, now, and JavaScript engine will not wait for anything, right? It has offloaded this task to libuv, it will move to the next line. It will see set timeout, it will again offload this to libuv. Okay? And moves to the another task, file read operation, it will again offload it to libuv. Right? That's how JavaScript engine works. And then it will execute this function, right? Multiply function with a and b value, and then it will do console log. Okay, so this whole program will run very fast, right? Like this. This line executed, this offloaded to libuv, offloaded to libuv, offloaded to libuv. This will run, this will run, this will run, right? And then all the code will run. And then now JavaScript engine will sit idle, right? Sit idle and will wait for some other task to be pushed inside the call stack, right? That's how things work, right? We already know that. This is just was the recap of the previous episodes. Now what happens when libuv, the tasks are uploaded to libuv. Now libuv internally does a lot of things to do all these tasks, right? Suppose there is a file reading operation. Suppose we gave this file reading operation, right? So what happens is, it is reading a file, it is making a call to operating system, it is reading a file, getting the data back, right? And then once the data is back, it is libuv's job to basically take this callback function and give it to V8 engine, right? What happens is, let me just tell you, it is libuv's job to take this callback function and execute, right? Over here in the call stack, once the file read operation is completed. Let me take an example of set timeout. Suppose this set timeout was of 5 seconds. Now, after 5 seconds, it is libuv's job to send this callback function to the call stack. And then once it is in the call stack, JavaScript engine will quickly execute it, right? But who will get this function to the call stack? How it will come to call stack? I'll explain you the mechanism behind it, okay? Just listen to me very carefully now. Pay utmost attention. This whole code will run inside this JavaScript engine, and the JavaScript engine now becomes idle. But suppose, okay, suppose this API call comes back, right? API call comes back very fast, but JavaScript engine is still busy running some JavaScript code, okay? Suppose this file has a millions of line, right? And JavaScript engine is executing one line at a time, million of line, right? Millions of lines of code, and it takes a lot of time. right? While the JavaScript engine is just executing a file, executing some JavaScript engine piece of code. So suppose this API call result has come in, right? Now this callback function has to wait inside this callback queue, right? This callback function has to wait inside this callback queue until the V8 engine is empty or it is idle. Suppose V8 engine is doing some job, it is running some JavaScript piece of code. You just can't directly push another function over here. You just can't do it, right? Suppose this JavaScript engine is busy and this API call returns the result. Now libuv, this callback function has to wait inside the callback queue for its turn for execution. Got it? So I'll give you more examples. Suppose this V8 engine is busy right now. Assume that this is busy running some JavaScript piece of code, right? So meanwhile, at the same time, this API call returns the result to libuv. Suppose at the same time set timeout also returns. At the same time file read operation also completes, right? All these asynchronous tasks completes at the same time. This can happen, right? Suppose API call is taking 100 millisecond, this file read is also taking 100 millisecond, and suppose the set timeout is also of 100 millisecond. So all these things will come at the same time for execution, right? All these callbacks will need to be executed at the same time, right? So what happens is, to manage all of this, libuv maintain callback queues. There are callback queues which are maintained, right? If the JavaScript engine is busy doing something, so all these callback functions have to wait in their respective callback queue. So there is a separate queue for timers, there is a separate queue for API calls, there is a separate queue for a lot of other things, right? So what I am saying is, if JavaScript engine is busy, libuv will hold these callback function in the callback queue and then later it will be executed, right? Once the JavaScript engine is finished and doing its task. Okay, when the call stack is empty, that is only something from the callback queue can be pushed inside this call stack. Got it? You have to understand this concept. Now, there comes our hero inside the libuv, which is event loop. What is the job of event loop? Let me tell you, event loop is kind of like a loop, right? It just keeps running, keeps running, keeps running. And its only job is to keep checking the call stack and the callback queues, right? Now the job of event loop is to keep checking the call stack and the callback queue as soon as, suppose if there are some tasks waiting in the callback queue, right? And event loop sees that, okay, now call stack is empty. JavaScript engine is just empty. It is not doing anything. So it will quickly take one of the tasks from callback queue and it will give it to call stack. Okay, it will give it to V8 engine to execute it. Let me give you an example. Okay, if JavaScript engine is busy running something, right, and this callback needs to be executed. The API call has given us the result. So this callback function over here, this will wait inside the callback queue. Now event loop is quickly keep on checking, okay, this V8 engine is busy, 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 busy. As soon as this V8 engine is empty, it will quickly take that callback function, it will push it inside the call stack, and V8 engine will quickly execute this callback function. Got it? Now, suppose if there is a race condition and all of these asynchronous things happens at the same time, right? And all of these callbacks are waiting inside these callback queues. Now, this event loop will have to prioritize something, right? How will this event loop know that, okay, should I run this callback function first? Should I run this callback function or should I run this callback function? So there is a proper mechanism how this event loop, because see, I'll tell you an example. When you run an application on production, then there are so many things happening on the server at the same time. There would be so many timers, there would be so many incoming requests, there would be so many file read operations, there would be so many API calls, so many things are happening simultaneously. So it is very common that these callbacks queues have a lot of things waiting. At the same time, so many things are happening. So it is very common that these callback queues have a lot of tasks pending. So it is the job of event loop to manage all of it. It is the job of event loop to manage all these callback queues and push these tasks into the call stack at the correct time in correct order. Remember, in correct time in correct order. And how and whom it will give priority, whether the set timeout should be given priority or whether API call should be given priority, all these things are managed inside event loop. We are going to see this in the next slide, that how event loop work inside the behind the scenes, because event loop is a very crucial task, right? It is kind of like a orchestrator, right? It's kind of like a orchestrator. It is keep checking the call stack whether it is empty or not, is v8 engine idle or not, and we also, there are different lingos to say it, right? So event loop checks if the JS engine is idle, right? So basically, see, event loop can only send some callback to the V8 engine when it is idle. You can also say V8 engine is idle, or you can also say call stack is empty. You can also say main thread is not blocked, right? Because suppose if V8 engine is busy, that means main thread is blocked. Okay, so there are different lingos for communicating the same thing, but if the JS engine is busy or it is not idle, event loop cannot push anything inside it, right? Event loop will have to wait for this JS engine to be empty or to be idle, call stack to be empty, or the main thread to be non-blocked, right? So if the main thread is not blocked, that is when event loop can give it. Why I am telling you all this lingo? Because in various, if you'll go outside, if you'll read some blogs, somewhere it will be written main thread is busy, main thread is not empty, main thread, everybody uses their own lingo. But that is why I want to say that, right? If suppose somebody says call stack is not empty, call stack is busy. So everything is being talked about V8 engine, right? Whenever you will read any blogs, articles, you see any YouTube videos, you should know exactly when I'm saying main thread, what do I mean? When I say call stack, what do I mean? When I say JS engine is busy, I mean the same thing. Okay. So whenever in this video also or in previous videos also, if I have said the same thing, it means the same thing. Okay. That JS engine is busy. Now let us see internally what happens inside the event loop. It's amazing, right? And not amazing, I would say it's complex also. But let me show you how this event loop works. It works in phases. Okay. And to talk about thread pool, I will come on to this later. Don't worry about it. Thread pool is also there, right? Don't worry about it. But you understood, right? That even libuv has a lot of things to do, right? To schedule all these asynchronous tasks in a non-blocking way. Okay, so let's go to another slide and see what is there in event loop. Okay, so now this looks like a very complex diagram, but don't worry, I will explain you in a very easy fashion. Listen to me very, very carefully. Okay, so event loop has certain phases. Okay, so event loop runs in a loop, right? It runs like this. Okay, it keeps running inside phases. So there are phases. There are many phases inside event loop, but there are 4 major phases which I am going to talk about. One is the timer phase, one is the poll phase, one is the check phase, one is the close phase. And all of them executes one after the other. The first is the timer phase, it goes to the poll phase, it goes to the check phase, it goes to the close phase. After close phase, it again goes to the timer phase, and it just keeps running in this cycle. So this is the cycle of event loop. Okay. Now let me tell you what does this cycle mean? Okay. So whenever event loop starts here, and event loop is in the timer phase, this is the first phase. In the first phase, in the timer phase, all the callbacks which are set by set timeout or set intervals are executed in this phase. Got it? Event loop will run in this loop. It will check whether there is some callbacks associated with the timer, right? Suppose if the timer expired, now a callback is waiting into a callback queue. Okay. Suppose the timer was expired and a timer callback is waiting, right, in the timer queue. So what will happen is event loop will first prioritize the timer callback. it will first prioritize the timer callback. After that, it moves to the poll phase. In the poll phase, all the callbacks associated with IO callbacks will be executed in this phase. Suppose if there are IO operations, suppose if you are reading a file, suppose if you are making some incoming connections. So suppose there are users who are making API call to your servers. So these are incoming connections. All of these callbacks will be handled in the poll phase. Suppose if you do fs.read file, right? I was doing in the previous slide, we did this fs.read file, right? This callback function will be executed, will wait in the callback queue and will be executed in the poll phase, right? In the poll phase. If you are doing http.get, if you are making an API call, just like we did, this callback function will be executed in this poll phase. Okay, if there is some incoming request, there are some IO. So basically, let me tell you in a nutshell that, okay, most of the callbacks will be executed in this poll phase. Okay, most of the callbacks, right? If you are making a file, if you are reading a file, if you are doing some API calls, if you are making some incoming request, if you are handling some incoming request, if you are running some controllers, a lot of callbacks happens inside this poll phase. This is very, very, very important phase. Very, very, very important phase. And we are going to talk about this poll phase in much more detail going forward, right? So don't worry about it. But what I'm trying to say, first of all the set timeout and set interval callbacks will be executed. That means this callback over here, this callback will be executed in the timer phase. Got it? And poll phase we have already discussed. Now what happens inside this check phase? There is a check phase. In this check phase, so there are some callbacks which are, so see, just like we have set timeout, we have set interval, there is one more function, there is one more utility API which is known as set immediate, right? This set immediate also takes a callback. So in this phase, all the callbacks which are waiting, which are scheduled from the set immediate and are waiting in the callback queue will be executed in this phase. Okay, so if you don't know about set immediate or you have never heard about set immediate, don't worry about it. I will show you the code example and I will show you how it runs, what it does and everything. Don't worry about it, right? But this phase, set immediate is run. Now this is the close phase. In this close phase, suppose all the close operations happen. Suppose you have opened a socket. Now you want to close the socket. So handling the socket on close will happen in this phase. And there are a lot of, basically this phase is basically kind of like a closing or a cleanup kind of a phase where we do a lot of cleanup kind of thing, like closing any sockets and a lot of other closing and cleanup kind of things, right? You can read more about this phase also, right? So, and you know, this event loop keeps running like this, right? It just keeps running. And meanwhile, it is also checking whether the call stack is empty or not, right? If the call stack is empty, it will quickly just schedule the callbacks accordingly, right? In this fashion, in this whole cycle. Got it? Now, if I have to explain you, right? Let me just explain you once again, right? Like in detail once again, right? So, let me basically recap all the things which I told you. So in event loop, first phase, there are 4 major phases. There are multiple phases, but 4 major phases. Timer, poll, check, close. First of all, timer, all the callbacks in timer will be executed. Then this poll will be executed. Then this check will be executed. Then close will be executed, right? Timer means set timeout and set interval. Poll means IO callbacks, right? Incoming request, data, file read, or you are doing crypto something, if you are doing http.get or something, right? All these things will be handled over here. In this phase, set immediate. In this phase, socket.onClose. And all these things, all these callbacks will be waiting inside this callback queue. Event loop will keep checking the callback queue for all these callbacks, and when the call stack is empty in the V8, it will quickly pick something from callback queue and will execute it accordingly, right? In this fashion. Now, listen to me very, very carefully. You understood these 4 phases, right? That it will run in a cycle. But listen to me very carefully. Before every phase, before every phase, event loop will also follow a inside cycle, right? What is this process dot next tick and promise callback? I'll tell you about these things also. So just like we have these set timeout, set interval, set immediate, we have there something known as process dot next tick. Okay, this is a way of handling some operations. You might not know this. I will come on to this in a while. Don't worry about it. But there is a way we can schedule some callbacks using process dot next tick. So, and there is a way we can, and there are promise callbacks also, right? Suppose if we have a promise and that promise is resolved, now there is a callback which needs to be executed. So that promise callback will be executed over here. Process.next tick callback will be executed over here. Now what happens is process.next tick and promise callbacks will be executed. This cycle will be executed before each phase. Before each phase, listen to me very carefully. It is very complex. You know that, okay? Event loop will run in this cycle, right? But before starting of each phase, event loop will check if there is a callback waiting for next tick, or if there is a callback waiting for promise.callback, right? It will execute these and then it will go inside a phase. So, right? Listen to me very carefully. It's very interesting also, and it is very amazing also. Okay, so this is the blue cycle over here, blue cycle. So this blue cycle will happen before every phase is executed, before it goes to every phase. This blue cycle will happen before every phase, right? I am denoting it with this blue cycle, right? So this blue cycle will happen before every phase. So now if I have to again explain you how event loop runs, let me tell you. First of all, it will start, it will check, is there something in process.next tick? It will execute it. Then it will go, it will check the promise callback. If there is some promise waiting, it will execute it. Now, once this cycle is complete, it will go over here, it will go into the timer phase. It will check if there is some timer pending, timer callback pending, it will execute it. Then it will again go and it will again go to the cycle. Is there process.next tick waiting? If there promise.callback execution, then it will follow this cycle, then it will come, then it will go to poll phase. Now in the poll phase, it will check if there is some callback pending. If there is callback pending, it will execute all of them. Now it will go over here, it will check, it will go again in the blue cycle. It will check process.next tick. It will execute process.next tick. It will go to promise. Then it will come back over here, then it will go to check phase. Then it will go again, it will go inside this cycle, blue cycle again, process.next tick promise. It will come here, it will go to close phase, and will keep running like this, my dear friends. This is what I explained you. A lot node developers don't understand it. There is a whole confusion over the internet about these things, that how event loop works. Right? This is the most confusing topic inside event loop, right? And this is why a lot of node developers never understand how event loop works, because it's very complex in itself. And when event loop was being developed, or when libuv would be making this event loop, I don't know why they made it like this. There might be some reason. I don't know how this thing happened, right? Why these things work in this fashion. But it is very tough for teachers also to explain. Whatever I am explaining you, it is very tough concepts. You ask your friends who are working in Node.js, you ask senior Node.js developers, they are not able to explain this concept. You will find a lot of articles on the internet which are explaining the same thing in a very different fashion, very different diagrams. Even if you go read the node documentation, it's very tough to get an explanation over here, right? Now when I have explained you all of this, now you go read any documentation, you will be able to understand that. Because making the mental model of how event loop is working is very, very important. Otherwise, you will not understand what is happening. You will not be able to answer any, you will not be able to answer any interview questions also, because a lot of interviewers just ask you these questions and you will not understand, right? They will ask you, when does process.nextTick callbacks are run? You will not be able to answer this if you don't know about this working. Okay, so let me just recap this working once again, but listen to me very carefully, because this is very, very important. If you understand this, you will understand a lot of things. See, event loop has 4 phases, right? Recapping it once again. Before every, it has one more cycle of checking the, so basically see, what does this blue cycle means? This blue cycle is basically kind of like, think of it as a priority cycle, right? I want to give spatial priority to the callback function inside the process.nextTick and the promise callbacks. I want to give it more priority. So this is kind of like a priority queue or a priority cycle. Now this priority cycle is executed before every phase of event loop, right? So when the event loop starts, right from the starting, first of all, it will check process.nextTick. It will check promise callbacks. If all these queues are empty, see, these are all phases, and all of these phases have their own queues. All of these phases have their own queues. So basically what I'm trying to say, all the process.nextTick callbacks will be there in a separate queue. All of these promise callback will be having a separate queue inside callback queue, right? All these timer callbacks will be there in a separate queue. All these poll callbacks will be there in a separate queue. All these set immediate will have a separate queue. Socket.onClose will have a separate queue, right? There are multiple queues which are being maintained by libuv, right? Now, how event loop works? First of all, it checks process.nextTick queue. Then it will check promise callbacks. It will execute it. Then go to timer phase. It will execute all the timer phase. Then it will again go to this internal cycle. Process.nextTick, promise, again goes to the poll phase. Now it will go back again. Process.nextTick, promise, come back, goes to the check phase. Now it will again go to the blue cycle. Process.nextTick, promise, goes to the close. And it will just keep running like this. Keep running like this. And meanwhile, event loop is also checking the call stack. If the call stack is empty, that is when it can only proceed to push any callback over there. If the call stack is not empty, event loop cannot do any of it, right? Nothing can be done if the main thread is blocked, because all these callback will eventually be running in where? In the main thread, okay? All these callback, whatever is happening over here, will only happen if my main thread is not blocked, if V8 engine is idle, or if my call stack is empty. Got it? Lot of people are not able to, so many developers don't understand all of it. It's very complex, right? So I am explaining you very slowly, because these concepts take a lot of time to sit inside the head, right? So it's complex, right? That is why I am telling you libuv. Inside the libuv library, there is a lot of code written to manage all this. You will find the code of this event loop, right? If you are interested, I will show you the code. Don't worry, I will show you the actual code. All this looks very fancy in the diagram, but at the end of the day, what is it? It is our C code. It is all code written in C language. All code written in C language. All these queues are also just like normal queues that we make inside C language. All of this thing is code. I am just explaining you visually so that it sits in your head. It is very tough, my dear friends, sometimes to explain this. It is very tough as a teacher also. You know, when I was preparing these slides and this episode, when I was preparing the content for it, it was very tough for me also to think, to explain all these things to you, right? It was very tough. So, but this is the easiest explanation. Let me tell you, if you understand this cycle thing, you will not be, you will not be confused anytime, right? And I will also show you code examples so that your knowledge just gets even more strengthened. Okay, so let's move ahead now. So see, now suppose in your code, just like you do set timeout, there is a callback function and 0. So similarly, there is a process.nextTick and you pass in a callback function, right? There is a promise.resolve and you can pass a callback function over here. You might already know this from JavaScript if you are a JavaScript developer. There is a set immediate and there is a callback function. There is a fs.fileRead and you have a callback function over here. You have a http.get, https.get, and there is a callback function, right? So there are a lot of asynchronous tasks and all these callback function goes into the queue, right? All these callback function goes inside the separate queue. All of them have their own queues maintained by libuv. Okay, now suppose if all of these callbacks are waiting inside their respective queues. Suppose, right? I'm just taking an example, a hypothetical situation. All of these asynchronous tasks are complete and all of these callbacks now are waiting to be executed in their respective queues. So how will things work? Let me just tell you. So how will these things work? First of all, the event loop will go. It will execute the process.nextTick, right? Basically, this callback of process.nextTick will be executed first, right? The first thing that will be executed will be process.nextTick. The second will be your promise callback. This promise callback will be executed in this phase, right? Now, after process.nextTick promise callback, the event loop will go into timer phase. So that means this callback from the set timeout will be executed, right? Now, once this happens, now event loop will go over here. Before going to poll phase, it will again check for process.nextTick. But now the process.nextTick is empty, so it will not do anything. Promise.callback is empty, it will not do anything. It will go back, it will execute the poll thing. Now inside this poll, see what happens inside this poll. This file read operation, this callback is inside this poll, and https.get callback will also be executed in this poll cycle, right? Out of these two are handled in the poll cycle, right? So that is why in the poll cycle, these two callbacks will be executed. Now event loop will go again and will check again if there is something inside process.nextTick. It's not there. It will go to callback, promise callback. It will not there. Then it will go and check the check queue. Now in this check phase, it will check for set immediate callback, right? So set immediate callback will be there in its respective queue. It will execute in here. Now it will go check the close phase. In the close phase, what will happen? It closes any socket connection or something, but there is no code of socket connection, so nothing will happen over here. It will again go to timer phase and will keep running this cycle again and again. Do you understand this or not? Right? This is the explanation over here. Okay, now right now I will just now I will take some code, real world code example and explain you how event loop works in the real world code examples. Okay, see, I have taken a lot of time to explain this cycle and I know a lot of you might have already understood, but there are some people who might take some time to wrap up their head around this concept. So that is why I'm explaining this to you again and again. Trust me, I have no intention to repeat all of this again and again, but I'm telling you slowly again and again because I want you to be very clear about how event loop works. Very important, right? Let me take code example now and I will again show you how event loop will run for that code portion. Now let us go over here and let me just show you the explanation of how this code will run. This is a real world code example, right? I will also show this execution of this code in VS Code, right? But first of all, let me just tell you that how this code will run inside V8 Engine using this event loop. And if you understand this, a lot of concepts will be clear. Okay, this is the real world code example and this is kind of like an output question to you. Okay, think about it as an output question, right? Your interviewer can also ask you this output question. I will explain you how it works. Suppose this is console, right? Let us see that how things will be printed inside this console when this code is run. Okay. So now, as you already know, all this code will be executed inside this V8 engine, right? So it will execute line by line. So what happens? It will first run const a is equals to 100. Then it will run set immediate. Now what will happen? As soon as it sees set immediate, this is a async operation, V8 engine will offload it to libuv. Now what will happen? This set immediate function will be executed by libuv, and this set immediate function, this callback function, okay, and let me call this callback function as a, okay. This callback function a will be scheduled, and this will go inside a callback. This will go inside a callback queue for set immediate, right? There is a separate queue for set immediate. It will go inside this queue, okay, and it will wait for its execution, right? Now it will wait for its execution, right? Because our V8 engine is busy. Our V8 engine is still running the code. This callback function will go into the queue and it will wait for its turn. V8 engine is still running this code, okay? Now it will do fs.read file. Now libuv will take this call and it will start reading the file, right? It will connect with the operating system over here and it will start reading the file, okay? Now it is start reading the file. But JS engine will not wait, because JS engine does not wait for anything. JS engine will move on to set timeout. Now if you will see this set timeout, it has a callback function. This callback function, let's call it B, okay? This callback function is B. What is this B? This callback function. Now you see it has 0 millisecond. That means we are telling the libuv that execute it quickly. We don't have to wait for any 0 milliseconds. So now this B function will have to wait in the queue because the call stack is empty. Call stack is busy, right? We are still executing this code, right? This whole code is being executed over here. The call stack is busy. So we cannot execute this callback function. So this B function will also have to wait in a callback queue. It will not wait in the same queue. It will wait in another queue. This queue is specifically for timers, okay? Let's assume that this queue is the timers queue. This queue is the set immediate queue, okay? So now this B function will wait in the queue. Hope you are understanding this, right? Now JavaScript engine will move on to this line. It will see that, okay, this is a printf function. It will move to the next line. Now it sees that, okay, printf function is called. So it will go and this printf function will be called, and finally a console log A will happen, right? This console log A will happen. Let's say console log A will happen. Now in the console, this line will be printed. A is equals to, and the value of A. The value of A is 100 over here. So let A is equals to 100 will be printed in the console. Do you see this? Now, event loop meanwhile is keep checking whether the call stack is empty or not, right? It is keep checking the call stack is empty or not. And it also checking, okay, there are some callbacks which are waiting to be executed, right? Event loop is checking meanwhile. Okay. Now this A is equals to 100 will be printed. What will happen now? It will move to the next line and it will be this console log last line of the file. This is the last line of the file. So now this will also be printed onto the console, right? Last line of the file. This will also be printed onto the console. Now the whole code is done executed, right? This execution is done. Global execution context will be moved out of the call stack and our call stack is now empty. The call stack, now think of a state. Now, right, just imagine a thing, right? You gave this code, JavaScript engine executed everything, A and B are waiting in the callback queue, right? Event loop is checking whether the call stack is empty or not. Meanwhile, libuv is also, this file read operation is still going on. It has not returned the result. File read operation is still going on. This is going on because the file might take some time to run, right? Suppose the file is large, it will take some time to get the data from the file, right? And these two are waiting. Now, as soon as the call stack is empty, now event loop sees an opportunity to schedule these callbacks. Right? Event loop sees this opportunity to execute this callback. Now, event loop will come into action. Right? Event loop will come into action. It will first of all see, is there a process.nextTick? No. Is there a promise callback? No. Now it will go to timer phase. It will say, is there a timer? Yes. In my timer queue, I have this B waiting, right? This B is waiting, right? B is waiting. B is this set timeout. Now callback queue will go over here in this timer. It sees in the timer phase, it sees that, okay, B is waiting. So now this B function will be given to call stack and will quickly execute it. Quickly execute it. Now event loop will execute this B callback. Okay, this B will go into the call stack, it will be executed. Now when B will be executed, console log of timer expired will be printed over here. Right? So timer expired will be printed over here. Timer expired. And this B function will be removed from the call stack. Okay. This B function will removed from the call stack. Now the timer queue is empty. Now this timer queue will become empty. Now, meanwhile, event loop after the timer phase will go to the poll phase. It will see, is there any poll, is there any callback waiting in the poll phase? No, we don't have any callback waiting for the poll phase. Now it will go to the check phase. Now in the check phase, it will check whether the set immediate is waiting. Yes, a set immediate is waiting. This A is set by set immediate. This callback function is waiting inside this queue. So event loop will quickly take this A and will give it to V8 engine. Now A function will be executed over here. Now when the A function will be executed, it will print set immediate onto the console. Set immediate will be printed onto the console, isn't it? Now our set immediate callback queue will also become empty. Now A is popped off this queue, right? It is taken out of this queue. Now what will happen? Meanwhile all this was happening, right? libuv was reading the file, right? That file read operation is going on parallel. In parallel, it will read the file, Now suppose after some time, this file read operation is completed. Let's call this callback function as C. Okay. So now, as soon as this callback function is this file read operation is completed, this callback function will now wait in the queue. Now there is a separate queue for this type of function, and this is the queue which poll phase will be executing, right? This queue is the poll queue. You can assume this is a poll queue. Just like there was one for timer, one for set immediate, there is one more queue for poll, right? So in this poll queue, this will be waiting, right? Now that as soon as this C comes in, our call stack is empty at this point of time. It is not doing anything. Event loop sees that, okay, there is a function waiting and the call stack is empty. It will just quickly again runs it. And will see that, okay, in this phase, there is something waiting. So it will just quickly take this C function and this C function will be executed. As the C function will execute, there is another console log will be printed, file reading CB, right? This file reading CB, and in the console, we will do file reading callback. Got it? Now, this callback function will again pop off the call stack. And now, everything finishes, right? Now the event loop does not have any job. JS engine is empty. All the callback queues are empty. Now event loop will just again wait if anything else come in the queues. Got it? This is how the whole thing works, my dear friends. Do you understand this or not? This is very, very tough to explain. I don't know if you understood this properly or not. I will take a couple of more examples and I will try to see, this is an easy example. I will just increase the complexity of these examples also, and then again will show you how event loop works. If you can answer this output question, that means you understood the event loop properly. If you can answer this output question, that what will be the output of this, you have understood the event loop clearly. Okay. Got it? Now, let me just go to my VS Code, and I have written the same code. This code that you see is written, this same code is written inside my VS Code, right? The same code is written over here. So we have a is equals to 100. We have a set immediate. We have a file read operation. We have the set timeout. We have print a. We have print a. We have console log last line. Okay. So now let us just run this code and see whether the output what we get over here, is this the same or not, right? Let us just see. But before moving over there, let us just dry run it. How the code will run? V8 engine will take this whole code and it will run, right? So first of all, what will happen? It will read this line, A memory will be stored. It will read this line, offload it to libuv. This will offload it to libuv. This will be uploaded to libuv. This will again initialize the printf function. It will call the printf function, and a is equals to 100 will be printed. So the first thing that will be printed will be, right? So the first thing output will be a is equals to 100, isn't it? 100 will be printed, right? A is equals to 100 will be printed. Now what will happen? This thing will be printed. Last line of file will be printed after this, isn't it? Last line of file will be printed after this. Now what will happen? Now our call stack is empty, right? Now our call stack is empty. Meanwhile, libuv has this callback and this callback is waiting. So now event loop will go. First of all the timer callback will be executed. So next the timer expired will be printed, right? The timers are given priority, right? Timer phase is the first phase. After the timer phase, set immediate will be printed, right? Set immediate will be printed, isn't it? Set immediate will be printed. Set immediate will be printed. And now after the set immediate is printed, after some time, this file read operation see, file read operation, there is a very subtle thing. There is a very common thing which people don't understand is, see, file read operation happens in poll phase and set immediate happens in check phase. But still file read operation will happen in the next cycle. So the set, because see, while the set immediate is being run, while the set immediate is being printed over here, by the time this is being printed, this file read operation has not completed yet. libuv is still reading the file. As soon as the file read operation is completed, this file reading callback will be printed over here, right? This is how this whole code will execute. Now let us just run this code and node. So this is the file event loop 1, okay? Event loop 1, and let me execute it. If I execute it, see this, all of whatever I said, right? All these things, what I was explaining it to you happened in just few microseconds. Just few fraction of seconds, all of this thing happened, whatever is happening inside. All this event loop quickly executing, checking the V8 engine, and all these things, pushing it into the call stack, everything is happening in just micro milliseconds. Think of you writing the code like this, and all of this executes in just like a blink of your eye. This is how things work inside computer science. This is how things work inside, inside your computers, how inside your servers, inside the Node.js. Such beautiful things are happening, right? We can just write this code very easily and we can run it in just doing this. But a lot of things are happening behind the scenes, and this is what not most of the developers understand. That, oh my God, I got this output, but how? All this happened behind the scenes, my dear friend. All this happened. And if we'll check, were we correct? Yes. The first thing that was printed was a is equals to 100. Last line of the file. First thing is timer, then the set immediate, then the file reading. Got it? This is how things work. Amazing, isn't it? Right? So it's very, it's very amazing to see all of it, right? Working behind the scenes. If you can visualize it in your head, it just, I just feel Node.js as very beautiful, right? How event loop works and all of it. It's just very beautiful if you think of it. When I think about this code, how this code will run, just think that you have slowed down the universe in a very nanosecond, right? Think about this, time is moving in nanosecond by nanosecond. That is when you can just feel the beauty of event loop and how things, what all happened over here, right? It's amazing. It's amazing, my dear friends, right? Uh, but anyways, right? Let's move to another example. I think I am taking a lot of time here. It has been a lot of time, but I am explaining it slowly because it's complex and I want you to understand this. If you understand this, you can challenge the interviewers. You go to the interview and you can challenge the interviewers that, okay, this is how things work. Ground level, fundamental, deep dive understanding, right? And these output questions are a little tricky, right? Because if somebody gives you this, you have to, if you don't understand this cycle of event loop, how it works, it becomes very tough for you to wrap your head around all of it, right? It's very complex. Right now in this code, we were just running the outer cycle. We have not even touched the inner portion of it. We have not used any process.next, take promise callback or something. But let's make this code example even more tougher for you. Okay. So let's go to the next slide. So this is the code example now. It is a mix and match of everything, right? Now it has set immediate. It has promise.resolve also, right? So we have now taken promise.resolve also. We now have process.nextTick also with us, right? Do you see this? We have process.nextTick, we have set timeout, we have file read, we have set immediate, we have printf function, we have all of things. We have some synchronous code. This is synchronous code, right? This all is synchronous code. This all is asynchronous code. This all things are handled by libuv, right? And now we have these code of all these phases, but we also have code for these two cycles, right? Now we will see how our code will output things up, right? Now we will again try to output things inside console, right? Think this is a console. Okay, my bad. I have made a very bad line. Okay, assume this is console. Let me make this console a little bigger. Okay, this is your console. Okay, console. Now let us just dry run it. Let us just see how this code will be executed. Meanwhile, I would want, if you are a smart developer, if you are learning from me, can you pause the video and try to guess what will be the output? You have a notebook and a pen, right? Take a moment, pause the video over here, try to guess the output of it. You already know how event loop works. Try to guess the output and then watch the video and then see me explaining you all these things. Got it? So let's just move ahead. Hope you would have you would have got the output, right? Pause the video if you have not. Pause the video, try to guess the output, then come over here and see how it works. Now let me explain you how it works. Again, all this code is executed inside the V8 engine, right? It will go line by line. So first of all, a is equals to 100. This will be offloaded to libuv, 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 right? All these things will be offloaded to libuv. When you are offloading this to libuv, there are some things which will take time, just like file reading will take some time, but these things will happen immediately. Set immediate will happen immediately. Promise.resolve will be resolved very immediately, right? Just in nanoseconds. Set timeout of 0 will happen immediately. Process.nextTick is again a function where you can pass in a callback and this will also be executed immediately. Right? So what will happen? Meanwhile, this code is running inside this V8 engine. It will go line by line. All these things will be offloaded to libuv. And what will libuv do? Let me tell you. As soon as this set immediate goes to libuv, suppose this is called a, right? So this a function will wait in a callback queue. right, of set immediate. Now suppose this is B. Now this promise.resolve has a priority queue. Okay, this is kind of like a priority queue. Let me make it in a different way, right? And similarly, there is a different queue for promise.nextTick. Okay, let me make two queue, right? For promise.nextTick and promise and process.nextTick. Okay, so now let's go back. Suppose this promise.resolve callback is there. This B will be scheduled in this queue, right? This is promise. This is process.nextTick. This is promise. Okay, now this is set immediate. Set immediate. Right? Now it will move on to this line. File reading operation will start. The file reading is not completed yet. It will take some time. Suppose it takes 200 millisecond or something. It will take its time, right? But these things will happen very fast, right? Because it happens immediately. It does not have to wait for anything. Set immediate of 0, because over here you have 0 timer. It will also happen immediately, right? It will happen immediately. Let's call this callback function as C, right? This C callback function will be scheduled in another queue. This is timer queue. This is timer queue, right? Now there is process.nextTick. Let's call this as D. It will also not wait for anything. It does not wait. It is not a time consuming operation. This callback will go inside its queue. It will go inside this nextTick queue, and this D will go over here. Got it? Now what will happen? While all this is libuv is doing all this code is running inside V8 engine, right? This code is running. Now V8 engine will continue to run the code, right? And this print A function will be called, and this will be printed onto the console, right? This will be printed onto the console. So A is equals to 100 will be the first thing printed onto the console, isn't it? A is equals to 100 will be the first thing, because this is synchronous code. All the top level synchronous code will be executed first. A is equals to 100 will be executed first. Last line of the file will also be executed after that. Wait, let me just write it down. Last line of the file will be executed now. Okay. Now, once V8 engine is finished executing this whole code, our call stack becomes empty. Once the call stack is empty, now it's turn of event loop to quickly check the callback queues. Once the call stack is empty, because till the call stack was running all this code, it cannot just push any of it, right? Callback, it cannot push any of these callbacks over here. Okay, now it is event loop job to run. How event loop will run now? You already know. Event loop will first of all go to timer. No, it will first of all go to process.nextTick. It will see in the process.nextTick queue, okay, D is there. It will execute it over here, right? And it will keep executing. Suppose there were multiple process.nextTick. Suppose if there was D, E, F. So it will keep executing all of these. It will keep executing all of this. Once this queue is empty, right, it will execute D. Right? It will execute D over here. And then what happens? D will be executed. If you check the D function over here, it will print process.nextTick onto the console. Okay, so let us print it up. Right? Process.nextTick will be printed over here. Now this queue will be empty. This will be popped off. So let us remove the D from here. Right? We have removed the D from here. Okay. Now this event loop after process.nextTick will go to promise callbacks. So it will check promise callback queue. It says, oh, B is here. So B will be executed in the call stack. Right? B will be executed inside this call stack. Now, when B will be executed, there will be a console log which happens. Okay. Now in this console logs, what will happen? Promise will be logged onto the console. Right? This promise over here will be logged into this console. Got it? Now this queue will become empty. Right? Let us remove this from the queue. Got it? Now what will happen? Event loop will continue running. It was running like this, right? It was running like this. It went to next. It went to promise callback. Now it will go to timer phase. Now in the timer phase, it will check the timer queue. This C is waiting. So C will be executed. The C function is timer expired. This timer expire will be printed into the console. So timer expired will be printed. Got it? Now what will happen? Timer expired is printed. This will move out of the queue, right? Call stack. So now let me just remove this timer. We have executed this. Now what will happen? Now event loop will go to poll. Now event loop will go to poll phase. No, my dear friends, it will go to process.nextTick, promise callback. It will find nothing because all these queues are empty. Now once this is complete, once it goes to process.nextTick, now it will go to poll. Now in the poll phase, is there anything waiting in the poll queue? There is a poll queue. This is empty for now, right? Right now this poll queue is empty, right? Let me make a poll queue for you, right? Suppose this is the poll queue, right? This is the poll queue. There is nothing over here because the file reading operation has not completed yet. If suppose, let me tell you, if suppose file read operation completed, meanwhile all this was happening, if suppose in the poll phase file read operation was completed, and let's name this as E. This E callback would have been scheduled over here, right? Suppose if the E callback was here. Suppose if this file was empty or if file did not take any time, right? So see, file read takes time. It cannot happen in 0 milliseconds. It takes time, right? So that is why it takes time. But I am taking a hypothetical situation. Suppose if E was present over here and the event loop came to poll phase, so it would have scheduled the E function over here. But file function takes time, right? File function takes time, so E will not be scheduled yet. So what will happen is event loop goes very fast. It checks the poll phase. It does not find anything. It will move ahead, right? It will move ahead. It will again check process.nextTick, promise callback. It will go to check. Now check is available. It will execute A. Now what will happen? Set immediate will be printed. Set immediate will be printed onto the console. Now what will happen? Set immediate will move out of this queue, right? This will be gone. Let me remove this. Let me put an eraser over here. Now what happens? Now event loop. Now this V8 engine is waiting. Now similarly, meanwhile libuv has finished the file operation because it will take time. Suppose it took 200 milliseconds. Now this E callback will be pushed inside this poll, right? Now this E callback will be pushed inside this poll. Got it? Now event loop quickly checks. Oh my god, there is something over here waiting for the queue. It checks callback, call stack is empty. It will quickly take this E, puts inside this call stack, E function will be executed and file reading will be printed inside this console. So now the last will be file reading, callback will be printed. Now tell me, my dear friends, was your output the same or not? Was your output same or not, my dear friends? Was your output same or not? Tell me, right? This is how things will work. Now, hope your output was same. If it was not, then go back to the video, watch it once again and see how I explained you in a very slow manner, right? How these things work. Got it? So now let's go back to our code, and in the event loop 2 file, I have the same code, right? If you'll go over here, I have the same code. I have set immediate, promise resolve, file read, set timeout, process.nextTick, print A, right? Cool. Now let us try to guess the output for it, right? Let us try to guess the output for it. So how the output will be? Let me just write this output on the top first of all, okay? Why not? So see, if you have to guess the output for this program, let me tell you How you can approach? See, first of all the synchronous code will run. What is synchronous code? This is the synchronous code. This is the synchronous code. All this is asynchronous code. So first thing is all the synchronous code will run. Any callback, all these callback cannot be, any console log over here in this callback cannot be printed until the call stack is empty. So it is a no-brainer. The first thing that will be printed will be a is equals to 100, right? Because you are calling this print function. A is equals to 100 will be the first thing printed, right? Now the second thing will be printed is last line of the file. And it's an irony, right? Last line of the file, but it is executed way before, right? Way before any callback is executed. Now after all this is printed, call stack is empty. Now it can take up this callback task. Now it will go into the loop. So always remember that process.nextTick has the highest priority. So if you see in the code there is a process.nextTick, so this will be printed process.nextTick, right? Process.nextTick will be printed. Now after process.nextTick, the promise will be printed, isn't it? Promise will be printed. This is how it works. Process.nextTick, promise. After the promise, if there is a timer, see the timer is 0. If the timer is 0, so the timer will be printed. Got it? Now suppose if we have timer, right? Now after the timer, it goes to the poll phase. In the poll phase, nothing will be printed because the file read operation will take time, right? It will go to the set immediate, then set immediate will be printed. Got it? And the last one will be file reading. Last one will be file reading. So it is that easy, right? You understood? Always memorize that diagram. You don't even have to like memorize or learn it or something. That diagram should be there in your head, my dear friends. This should be there in your head, right? Let me clear the console and let us verify our output if it works the same way or not, right? If it works the same way or not. If I go back, if I run node.js event loop 2 file, right? If I run this file, see this. Is it in the same order? See this. All of them are in same order. A, last line, next tick. Where is promise? Oh my god, promise was not executed. Promise was not executed over here. Am I writing it in a wrong fashion? Okay. I am doing it in a wrong way, okay? So promise.resolve, basically I have to do like this, okay? My bad, I wrote the code in a wrong fashion. Basically, and do a dot then, right? Basically, you have to resolve it then, and in that then you need to pass a function, right? So it's the same thing, right? So basically, I'm creating a promise and I'm just resolving it with the keyword promise, and it will automatically quickly resolve it, right? And it will call this console log function. Okay, save it. Now, if I do this once again, see this. Now you got this right. So synchronous code, process.nextTick, promise, timer, set immediate, and file reading callback. Okay. So this is what we were expecting. So this is how this example will work. Okay. You understood, right? How beautiful it is. That, okay, it does a lot of things behind the scenes. Okay. Now let us move to another example and it will be very fun. Let me tell you last example. Okay, please. Right. Not the last example, but I want to tell you an important thing, right? And you know, these are easy examples still. There is a very complex examples also. And let me just explain you. That is when it will make sense. Okay. Let's just go over there. I have to explain you one more concept. And this concept is that, okay, see, event loop keeps running. You know how it works, right? It keeps running from one phase to another phase to another phase to another phase to another phase. And in between each phase, it is running this also, right? Before every phase, it is running the inside circle also, right? So basically, this is how event loop works. You already know. But listen to me over here, that event loop waits at the poll phase. Now, this is again a tricky concept, which is tough to explain, but listen to me carefully. Let me explain you. You know that event loop, keep going over here, keep going over here, keep going over here. And it also checks the callback queues. It also checks the call stack in the V8 engine. if it is empty or not, right? It is doing all of it things. But suppose if the call, suppose if the event loop is idle, right? Suppose if the event loop is idle. Suppose if there is nothing in the callback queue. Suppose if there is nothing in the callback queue. Or let me take an example, okay? One more example I will take, okay? So let me explain you with previous example itself. So what happened is, see, when the event loop was running, it executed all the timers, it executed all the checks and everything, right? All these queues are empty. But there was file reading operation still going on. So when the file reading operation was still going on, that was a phase where JavaScript engine was also empty. All the callback queues are also empty. So event loop has nothing to do. So in the idle phase, when the event loop is idle, when the event loop has nothing to do, so what happens it waits in the poll phase. So what I am trying to say, when the event loop has checked the timer queue, it has not found anything, 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 it has not found anything. So when the event loop is running like this, it will come and wait at the poll phase. And it will wait at the poll phase. So suppose something came in the poll phase, it will start executing poll phase again. And it will start executing like this, right? But if it has nothing to do, it will wait at the poll phase. So this is very important. Event loop wait at the poll phase. A lot of people are confused with this concept, and let me tell you, this is an advanced level knowledge of event loop. Advanced level, right? This is one more level complex than what most node developers understand, right? Understanding this is easy. Understanding this is easy. Now, event loop basically waits over here. If everything has been done, if the call stack is empty, callback queues are empty, it will wait over here for any poll event to occur. Got it? It will wait at the poll phase. So now, and let me also tell you, some front-end developers might confuse this event loop with the event loop which is there in browsers. So let me tell you, event loop which is there in browsers is very different. Event loop over here is very different. Okay, so both of the implementations are very different. Don't confuse it with the browser. So in the browser, the event loop keeps running. Over here in the node, when event loop has nothing to do, it just don't keeps running. When it has nothing to do, it just waits at the poll phase. It waits at the poll phase. So some people call this as an semi-infinite loop. Why? Why? Because it's a semi-infinite. Because when it has nothing to do, it just waits somewhere. When it has something, it just again goes to the cycle, right? So it's kind of like a semi-infinite loop. It also waits over here in the poll phase. How can I show this to you? Right? And let me tell you an example of that also. So see, suppose if you have an incoming request, suppose if you have a website, suppose if you have made an API call. So there are so many users requesting your website, right? But there would be time when nobody is requesting. So the event loop will wait over here. Suppose if one new user came into your website, so this call will come in, it will go into the phase pool and event loop will again start, right? But it will wait at the poll phase. Now I will show you one more example, right? Now I will show you one more code example, and if you can give the output of this example or not, right? Let us see if you can give the output of this example. Pause the video once again. It's an interesting example. If you can answer this, then I will just announce that you are a very advanced, very good Node.js. You have very good understanding of Node.js, how it works behind the scenes. If you can explain me the answer to this example, okay? Can you give the output? Pause the video and give the output, okay? Console, pause the video and give me the output. Can you give the output, my dear friends? Pause the video and give the output, okay? So let me just remove this. This is the console over here. Okay. This is the console. Okay. So pause. Hope you have done it, right? Come back. Now let me explain this to you. It's an interesting example, my dear friends, right? It's a very interesting example. Tell me the order of execution of all of it. right? So again, I will not start from the scratch of all these things will be executed and all that. I will just quickly go over it. Right? So first thing is all the synchronous code will be executed. Over here, there is no extra synchronous code, only the last line of code. So the first thing that will be printed over here will be the last line of the file, right? So the first thing will be printed is last line of the file. Okay. This is the only synchronous code is there. Meanwhile, while all of this is happening, libuv, all these things are offloaded to libuv. Now libuv will store these callbacks inside the callback queues, right? So let me store it. So the first thing is set immediate. So it will go to the set immediate callback. So set immediate callback queue, right? Over here, set immediate. Let me call this function as A. It will go over here. Then set timeout. Let's call it as B because it has 0 over here, 0 timeout. So set timeout. This is the timer queue. The B will go over here. Now promise.resolve is also happening very quickly, right? So this is C. So it will go to the priority queue, right? It will go to the promise queue. Suppose this is promise queue. Assume this is promise queue. This C will go to the promise queue. Now there is a file read operation. This operation might take time. This callback function over here, understand this callback function. This whole callback function will take some time to execute. Okay. Suppose it takes 100 milliseconds to execute. Meanwhile, libuv is executing this. The code will go over here, right? So the process.nextTick will be scheduled. So the process.nextTick will be scheduled. This next tick will be scheduled and let's call it as D. Okay. This process.nextTick will be executed. Next tick. Okay. So now all these are scheduled and this console log is printed, right? All this, how the code was run. This was scheduled, this was scheduled, this was scheduled, this was went to the fetch the, right? So this file reading operation is happening inside libuv behind the scenes. Process.nextTick goes over here and console log happens. Now the call stack is empty. Now event loop comes into picture, right? Event loop goes to the, first of all, goes to the process.nextTick. It says D, so it executes D and it prints next tick into the console. Let's print this next tick. Next tick is printed. Now it goes to promise, right? It will goes to promise, right? It will execute the C function. It will print promise. Got it? Now what happens? It goes to the timer phase. It will execute the timer, right? Timer expired. Now after the timer phase, it goes to the poll phase. Poll queue is empty right now. This is the poll queue. Okay. The poll queue is empty right now. It will not do anything. It will go to check queue. It will see set immediate. So it will execute the A function. It will execute the set immediate. Now what will happen after some time and all these callback queues will be empty now. Let me remove all these callback function. D is gone, C is gone, B is gone, A is gone. Now after this callback function from this fs file read, let's call it as E. What is E? E is this callback function. This whole callback function is ready to be executed. It goes to the poll phase. Now the file reading operation has complete, right? So let's say this E goes to the poll phase, right? This is how it will work. E goes to the poll phase. Now event loop sees that, okay, call stack is empty. There is a poll phase waiting. And meanwhile, the event loop is I told you, right? In the previous slide, what will happen when the event loop is idle? It will wait at the poll phase. When the event loop is idle, it will wait at the poll phase. So what is happening is, while all these queues were empty, event loop ran once and then it was waiting for poll to finish, right? As soon as the file reading operation was complete, E was pushed inside this and this E will go into the call stack and E will execute, right? Now how this E will execute, let me tell you, right? Now let me tell you, it is an amazing process of how this E will execute. This function will again go to the call stack and it will start running line by line once again. So now I am just focusing upon this inside function, right? Now it is the execution of just inside function. To make things clear, let me just remove all of it, right? Let me just clear all of it. Okay, now we are just focusing upon this portion of the code, right? This portion of the code. How it will run? Now you know JavaScript is a synchronous single threaded language. It will run line by line. Now it sees set timeout. Now V8 engine again sees set timeout. It will offload it to libuv. This set timeout callback function, the second timer, this callback function will now go to set timeout queue. Process.nextTick goes to the process.nextTick queue. Set immediate will go to the set immediate queue. And then console log will go to over here. So what will happen is, first of all, this set timeout will go over here. Let's call this as function f. Okay, this is the callback function f. Let's call the f e f g. Okay, this is g. This is h. Okay, f g h. Now f g h will also go to their respective queues. Now set timeout queue, f is over here, right? G is in the next tick. G is in the next tick queue, right? And now set immediate goes into the set immediate queue. This is H. Okay. And what happens? There is a console log. Now console log file reading CB happens, and file reading CB will be printed, right? File reading CB will be printed, and then this function execution will complete, right? This E was running, right? This E was running inside this call stack. So it just F, G, H were scheduled in their respective queues. And now console log will be printed. Now this E will move out and this E execution will be done. So all this will be gone. This E will be gone now, right? Where is the event loop? Event loop is in the poll phase, right? It has executed the E function. This whole function. Now, the event loop now will run like this, right? Event loop will not start from the first. A lot of people gets confused that suppose if this is a file reading operation, when this callback will be called over here in poll phase, the event loop will not run again from here. Event loop will wait over here. File reading callback will be executed. Now the event loop will continue from here, right? How it will continue from the poll phase? That E function was execution, right? The last thing which was executed was the E function over here. So E function was in poll phase. So the poll phase, it will go again. Before going to the check phase, it will check the process.nextTick. And you will see that there is a process.nextTick. So it will execute this G function. Then it will check for promise, then it will go to the check phase. That it will not go to timer. After the poll phase, it will go back again to the process.nextTick, then promise, then check function. Okay, so now when it goes to the process.nextTick, this will be executed first. So basically G function will be executed and second next tick will be printed. Next tick will be printed, right? After the second next tick, set. Now see, now there is a confusion. Okay, so this is gone. Now the major confusion is that should set immediate will be printed first or set timeout. The event loop works like this, but the cycle is currently over here, right? The cycle is currently over here. It has executed next tick. So now check function will be executed first. So H will be executed first. Okay, so H will be executed. H is what? Second set immediate. Okay, so the second set immediate will be called, right? And then second timer will be called. Got it? And that's first set immediate will be called. Then it will go to close phase. Then it will go to timer phase. Now the F function will be executed. Got it? So this is how things work. If you understood this, then you understood the internals of how event loop works, and this is very, very complex. A lot of developers don't understand this. Mind blows when you see all of this, right? Mind blows when you see all of this, right? This happens in fraction of seconds. Behind the scenes, all this is happening. Now let's go back to our code over here, and let us go to third file. This is the same code which we saw. Now let us just quickly try to dry run it, right? And then we will execute it. Okay, so let me just tell you, first of all, last line of code will be printed and all of this will be scheduled, right? So last line of file will be printed, right? The first output, let me write the output on the top. What happens? Last line. The first thing that is being printed is, let me just make this over here. Okay, the first thing over here, I will write the output. The first thing that will be printed is last line of the code. Okay, what will happen after that? The process.nextTick will be printed, right? The next tick will be printed. That's how the cycle works. Next tick will be printed. After the next tick, promise will be printed, right? After next tick comes the promise. After the promise, timer expired will be printed, right? Timer expired will be printed. Now set immediate will be printed. Set immediate will be printed. Now what happens is, after set immediate, my file reading operation is complete, and now this callback function will be executed, and in this callback function again you will follow the same process. First of all, file reading CB will be printed because this is the synchronous code, right? This is a synchronous code, right? This is synchronous code. It is on the top level. File reading CB will be printed. Now among all these three, what will happen? Next tick will be printed first. The second next tick will be printed, right? Second next tick will be printed. Now over here, when the second next tick will be printed, now set timeout on set immediate are waiting. But the event loop is at what state? It was in poll state, right? So after poll phase, it comes the set immediate phase, the check phase in the set immediate. So the second set immediate will be printed. After second immediate, the second timer will be printed. Okay, so this is how the code will run, my dear friends. If you have understood this, you have understood it a lot. If you have understood it in a very good way. Okay, so I have written the syntax incorrect over here once again. Let me just fix it. Promise.resolve, and I will resolve it with a string. Promise, I will resolve it with a string, and I will resolve it immediately, right? I will do a then, and on calling the then, I will just use console.log. Cool, right? So now if I save and if I run this file, so see the output once, okay? So let me just run this third file. See the output. Do you see this? It is the same what we anticipated, right? So this is how it is. I would request you, if your output was not correct, if you were not able to get the same output, think about it once again, retry it, and then come back to this video and we will move ahead, right? I know I am taking a lot of time. It has been a lot of time. This video has become a lot longer, right? This episode has become a lot longer, but trust me, this is a very, very, very important episode. If you understand all of this, you will be like getting a lot of cool knowledge out of it, right? This is amazing. You understand how Node.js works. Now, we will move on to understanding a lot more about, and before going that, let me just show you one more last example, right, of the event loop. Then I want to show you the thread pool also. Then we will talk about thread pool later on. But before that, I want to give you one more example. Okay, I want to give you one more example over here. Right, I want to give you one more example. Let's go back to the code. Over here, let me show you one more example, okay? So this is again an output question to you. I will not be making a diagram and showing it to you how it works, right? I will not be making this diagram now for this output question. Let us just try to see that what will be the output of this question. This is again an output question to you, right? Just try to find out the answer for this, right? Okay, pause the video and try to find out answer. Okay. So now let me explain you how this code will once work. right? Then we will move on to thread pool, that how thread pool works and what is thread pool and all, right? It will be very interesting. Just give me some more time. I know this video is getting longer, but I want to finish everything in this one video itself. Or maybe I can break it down into 2 videos. I can make a part 2, but let me just first of all explain this to you, okay? Whatever is over here. Okay, so now let us just output this. So this whole code will run. So first of all, the last line of the file will be printed. You already know this, why, right? So first thing is printed, right? This is how it works. Last line of the file will be printed. Let me make a multi-line comment so that it's easier. Okay, so the first thing is last line of the file. Now what will happen is all these functions will be scheduled, right? Now out of all these, which has the highest priority? The highest priority is of next tick. So the next tick callback function will be executed, right? The next tick callback function will be executed. Now if you will see the next tick callback function, it is recursively calling next tick again. It is recursively calling next tick again. So what will happen when this callback function will be executed, my dear friends? So the next tick will be printed. And you know what will happen? If there is a nested next tick, so this inner next tick will be printed before even going to any other thing, right? Before any other callback, if suppose next tick function is there inside the next tick, so what will happen internally? It will keep executing till all the next tick is clear, right? So what I am trying to say is next tick callback queue has the highest priority. If there is a next tick function over here, callback function, and it is that next tick function callback has another next tick, it has another next tick, so it will keep calling this again and again, so it will move to the phases, it will move to the next phase of event loop only when the next tick queue is empty. Only when the next tick queue is empty. This is what I want to show. So the answer of this will be next tick, then inner next tick, then what? Then out of this what? Promise. Okay, then there will be promise. Okay, and let me copy the promise. This syntax is again wrong, right? Let me just copy. I have written this example very fast, so that is why this syntax is a little wrong. Don't worry. Okay, then the promise. After the promise, what happens? After the promise, we will go to the timer phase. So the timer expired. Okay, timer expired. Okay, after the timer expired, we will go to the poll phase, but there will nothing be in the poll phase. File reading will take some time. We will go to set immediate. And after the set immediate, we will have file reading callback. Okay, this is how the output will be. Let me just run it and show it to you if this works the same way, right? Event loop 4 file. Cool. So last line of the file, next tick, the inner next tick, right? Okay, I have not written inner next tick, but after next tick, there will be inner next tick, okay? So don't you worry. Okay, this inner next tick, I have not written it over here. Inner next tick, promise, timer, immediate, file reading callback. Okay, this was it. Now, I wanted to explain thread pool and a lot of things in the same video, but I think this video is going a little longer. You will be bored. I feel you should take a break. Why I want you to take a break? Go back to the previous slides and everything, right? And come back once again. Practice these examples in your code. Until and unless you write code, it will not work, right? It will not work. My dear friends, you will not understand it. Write code. Play with it. Try to put a promise inside a next tick. Try to put a next tick inside a promise. Try to put a next tick inside a set immediate. Try to play with this code and try to do all the output questions. If you understand this, it makes you a great Node.js developer. Okay, this was all in this video. I am also getting tired. My throat is aching. So what I will do is I will make another video and then I will explain you thread pool. I will answer the famous question of interview, is Node.js single-threaded or multi-threaded? Very amazing question. I will tell you what is a thread pool, what is a thread pool size, how event loop works in with thread pool, is thread pool required or not, and a lot of other complex things inside libuv. See, this libuv is a very important portion of Node.js. So libuv explanation has core things. We have seen event loop and callback queues. Now we will talk about thread pool and how libuv deals with operating system. Okay, in the next episode. So go back, take down notes, revise everything, and then I will see you in the next episode. If you're liking this, I want to ask you a famous question, my dear friends. Are you liking Node.js or not? Have you fallen in love with Node.js or not? The mission of this series is to make you fall in love with Node.js, my dear friends. If you have still not fallen in love with Node.js, we have more episodes. I will make you fall in love with Node.js. And if you have fallen in love with Node.js, go to social media, write about that I have fallen in love with Node.js. Share the learnings of this episode. Whatever I have taught in this episode, summarize it. Make a post out of it. Put it on LinkedIn. Put it on Twitter. Put it on Instagram or anywhere. Write your notes. You can share your notes on social media. Right? And also, please, if you like whatever I am teaching, see, all of this, explaining all of this takes a lot of time and a lot of efforts to draw all of this, explain you in an easiest fashion, dry run all these programs. And trust me, my dear friends, nobody on the internet, no teacher will explain you like this. Tell me a teacher who is explaining like this till today. After this course, I don't know if somebody is explaining you like this. But trust me, it takes a lot of efforts, pain to explain you everything, show you the code demo, explain you a lot of things in detail. I also wanted to show you the actual code of event loop, how event loop works, the official documentation and everything. But I feel this video is getting a little longer. But I want you to please appreciate the efforts. And please, if you can do it, one request, please share about us, share your learnings on social media, tag me in that post, spread a word about Namaste Node to your friends, family, social media network. That would mean a lot to us. That is all in this episode. That is my last request. Thank you so much. Wish you the best for your interviews. A lot of questions come from this episode in interviews, how event loop works and how this process.nexttick works and all of it. Please practice it a lot and then come back and we will talk about thread pool and a lot in another episode. Okay, bye-bye. See you in the next episode. Bye-bye.